We are joined by Brett Morgan, Firebase Studio DevRel engineer at Google, who is here to talk about how you can customize Gemini CLI for your workflow. With over 77K stars on GitHub, Gemini CLI is becoming one of the fastest growing tools, and Brett will show you how to make it your own using Model Context Protocol service and Gemini CLI extension. Please join me in welcoming Brett Morgan. Brett, the stage is all yours.
Oh, you want to see? Okay.
No, we have like 5 minutes break right now.
Yeah, but I just prefer to sleep.
1, 2, 3. Can you hear me? Sweet. So hello, I'm Brett Morgan. Wait, I've got a slide for this. I have been at Google for a very long time. I've been there so long, I'm officially part of the furniture. I'm at the point now where we're seeing VPs resign, and I went, I remember when they were in L4. It's a crazy time at Google. I have been a DevRel for a bunch of products, Blogger, Google+, Google Maps, Flutter, and as you just heard, another one. But these days, my primary focus is Gemini CLI because that's where the magic is, in my humble opinion, which means that my new career is now Markdown engineer. This is only partially in jest. So I'm going to carry through a few things today. I'm diving into a hobby that I've just picked up thanks to a friend who basically pointed me at a soldering iron. And I said, I haven't used one of them in 4 decades. And he went, time to start. But it serves as a useful exercise in finding things that Gemini CLI can and can't do, or Gemini can and can't do. The fun thing being that what I saw Gemini doing yesterday versus what I'm seeing Gemini do today are completely different. So there are parts of my talk that will probably work that weren't working yesterday, so that could make fun for you guys to laugh at me as I turn around and completely contradict the demos. But that's okay. So, some background, audio electronics. Here's a hobby I have picked up. No, this is not me, but it is an expensive hobby. Each one of those little panels there, they start at about $100 and go up from there. Please don't tell my partner. So I'm starting small. I got a little $3 kit off AliExpress. It came with some wonderful instructions. Thankfully, Google Translate is helping me out because no, I don't speak Chinese. And I also have the advantage that the board, yes, it is upside down, is well labeled. So I can sit there with a multimeter and figure out the resistance and capacitances of all the bits and pieces and put them in the board. Solid it up all nicely. And of course, the immediate question you ask is, to which the resounding success is, no, it doesn't. Now, I'm old enough. Yes, this is grey hair. I've had it since I was 18, but it's just been filling in. I am used to being able to pop open a shell, drop some logs, and figure out what's going on. Turns out, when you're getting into electronics, where the most impressive piece of silicon on that little board is actually older than I am. Well, not that specific chip, but the chip design, the NA555, the timer chip, it was actually designed in the late 60s and has been in series production ever since. So it's an impressive piece of silicon. So let's dive in and actually have a look at the circuit. No, there's not going to be a test. What I'm doing here is something that you need to get used to with when you're dealing with Gen AI. You need to bring judgment to the table. And what do I mean by judgment in this case is you need to be able to figure out when the LLM has fallen off and is just starting to gaslight you. So let's dive in and learn some basic electronics. Click. So here's where I thank an ex-colleague of mine, Thea Flowers. She wrote this wonderful little web application. Boop. So let's just walk through this circuit really quickly. On the top, we have a barrel jack. This is where we plug the power in. There's a little diode there for doing reverse polarity protection. Here's the NE555. That's the timer chip. It basically, based on this configuration of resistors and capacitors, just sits there and oscillates between full power and power off on this Q line. This is the output, so it generates a square wave. We have a bunch of capacitor resistor networks where we move from having just a square wave coming out to a saw wave, which goes straight up and then dies off, and goes straight up, dies off, to a triangle wave, because we're basically charging and discharging these capacitors. So you've gone from square to saw to triangle, and finally, down here with this transistor capacitor network, we wind up with a rough approximation of a sine wave. So what we're doing is we're taking something that has all of the overtones. So you've got the pure tone that you're generating plus the overtones above it, like a square wave has all of the odd overtones above, and you're slowly but surely trimming them off. And you basically get different sounds. Down here, we have a bunch of ways of selecting which one. So you can connect the square wave or the triangle to the output, which is this guy here. This is basically the amplifier that takes the soft signal and connects it through this transistor to the speaker. There's a little capacitor here that does a thing called AC coupling, which I won't get into. Okay, we've got a speaker. Problem for me is when I look across these two pins with my digital multimeter while it's plugged in, I don't see varying voltage. So there's something wrong with my circuit. It'd be really nice if I had something that I could sit there and ask questions of to help me debug the circuit, because undoubtedly one of my soldering jobs has gone sideways. So how do we do this? Back to the slides. No, not like that. So let's talk about Gemini. Who here has installed Gemini CLI? A couple of you. Sweet. For those of you who haven't, we now have a wonderful website. This happened about a day ago. There's a bunch of ways on there. This one is not listed. This is my preference. The reason why I use this one is that, near as I can tell, the CLI team are pushing out a new release of their tool every 4 hours or so. So by using the npx-y, you get the latest one, which means while I'm doing demos, you will see the spinning dance of, yes, I'm downloading a new version. Okay, let's get into the demo. Probably need that a little bit bigger. How's that look? Can we read? There we go. Okay. And I am going to save myself from typing by stealing things. So here's where I turn around and ask Gemini to go and do something useful and look at a schematic for me. The great thing about this schematic is that, as you will see in a minute, it's all in a scheme-like language. And here's where it should have fallen over, but now it isn't, because apparently our data centers have more capacity. Let's have a quick look and see if I can spot the mistake, because there's usually a mistake. Yeah, all this 555 stuff is basically, haha. Okay. Here's the fun part about supplying too much context to a LLM. When you give it too much, it will lose its mind. And unfortunately here, what it's doing is giving you what is usually happening when you have a potentiometer in a circuit like this. It is usually for controlling a voltage input which controls a frequency or a duration or something. And so that's what it's guessed. It's just gone, okay, this potentiometer is for adjusting a frequency. It's not actually, it's for adjusting the volume. So how do we fix this? Here's the problem. As I explained, there's a lot of data there, about 7,000 lines in that KiCad schematic file. Is there a better way to represent circuits for analysis? Let's ask Gemini. Yes. So, Gemini, please help me. Come on, you can do it. Thinking, thinking, thinking. Hopefully, if the data centers are on my side, interpretive dance. There we go. Oh God, it's a wall of text. But the important thing is, yes, we've got the word netlist. What is a netlist? Netlist is a way of representing a circuit based on components and the circuits, the traces, or the nets as they are called, that join them together. So what we're going to do is, well, we're going to cheat. We're going to ask KiCad, which I wrote I drew the original circuit that I showed you in, to export a netlist for us. In fact, I've already done that. So if I drop out and look on the disk, you can see that there's a 555 oscillator, KiCad shut, that's the schematic file, and there's a .NET file. .NET file is a little bit smaller, so let's have a look and see what happens if we ask Gemini to, instead of reading the big thing, to read the little thing instead. So what I'm doing here is trying to cement something in your mind, which is be selective about what you feed your LLM. Give it signal, not noise, basically. It's a little bit hard to follow, but I think usually when I run this, oh, yes. So the thing I was picking on the last one, it is not a frequency control, it's a volume control. So bingo, suddenly a much better solution because I went from a 7,000 line file to a 700 line file, 762 to be exact. Okay. So we can generate a netlist using this command, which I already did, saving time. We've gone from 7,000 lines to 700 lines. We get a better result. So we've seen what happens. We get a netlist. Netlist is better. What happens if we scale up? I'd like to introduce you to this. I know there's a shop in the URL, but unfortunately this company is no more. So this is purely past tense, not present tense. But on the upside, again, this is the person who did the KiCanvas stuff, which I was showing you before. Thea Flowers. This is open source hardware. So you can do what I'm about to do, which is, well, firstly, look at it in real life. Anyway, we're going to dive into what is actually behind this. Crunchy, crunchy, crunchy. Okay, so the first thing to notice is we don't have one file, we have a bunch of files. There's a whole bunch of stuff here. We've got some power input, we have regulators, we have voltage references, we have an MCU, a SAMD21 for those of you who are into the Arduino market. We have a bunch of analog inputs. Those are the jacks you put things in. There's some TL72s or TL74s probably. Actually, no, these are the MCP6004, which is a more digital fasting one. The fun part is we've got a Castor and Pollux. Those of you who know your, I think it's ancient Greek, they're twins. So hilariously, these are actually the same file, but there's two of them. So you wind up with two voices that you can mix together, you mix them together, so on and so forth. So the fun thing is, when you turn around and I'm not going to ask Gemini to look at the schematic file because way too big, but even the generated net file is still about 5,000 lines of code. So let's dive in and see how Gemini handles reviewing a large net file. More interpretive dance. By the way, feel free to shout out during this if you see something and you want to point out that I'm being silly. That's perfectly fine.
So is this the same context as you used previously with the previous schematic, or have you started a new context?
It's actually the same context. I could probably be nicer to it and kill the current context and start again. And I'm going to do that the old-fashioned way. Yes, there is a /compress, I think, but let's give it a completely fresh context. I think it was actually doing a reasonable job anyway. It was doing a much better job than it was yesterday. Given the whole point of this exercise was to show you Gemini failing and then showing Gemini succeeding. But this is the joy of doing a demonstration live on a Saturday with something that rolls dice for a living. Okay, I'm not going to go through this output with a fine-tooth comb and find the mistakes, but this actually looks like a reasonable output. So the next slide where I say, why did it fail, we're going to change that mid-flight to, how could we make this better? So the primary problem here is the main board, even by going from a set of schematic files down to just the net list, it's still a fair amount of content. And what my talk is really about is how can we boil this down to something that's just exactly what it needs. So what we're going to do is we're going to have a look in a file and think about what we can throw away. So here's a netlist file. So this is the netlist file for the smaller circuit, the 555 base circuit, and I'm pretty certain you can probably spot something. There's a whole bunch of stuff here which has absolutely nothing to do with what we want Gemini to concentrate on, which is the components and the connections between those components. So I'm going to ask Gemini for even more help and get it to do some coding for me. And again, I'm going to reset context. So here's where I find, personally, again, I'm not claiming any expertise here. This is something I've just been playing with for a year. Here's where I find LLMs really useful, being able to take a chunk of content and try and distill it down. And what I'm doing here is going, okay, I've got this data file. I kind of know what its structure is, but I'd like you to give me a first pass at a data structure for it. So I've asked it to read that file. It's only 700 lines long, and it's come up with a structure, design, some components, some libraries, some nets. This, I think, is a reasonable summation of what it is. I'm actually a Flutter Dart developer by trade, so I'm going to use Dart. Use whichever language you like. It knows most of them pretty well. Python and TypeScript are probably the best if you want stuff that they've been trained on, but I prefer reading Dart, so that's what I'm using. So the upside here is that, sure, what could possibly go wrong? So it's just written out some code for me, and to make it easier to understand what's going on, I'll also ask for a class diagram. So what I'm getting at here is that if you're in a realm where maybe you're doing some consulting work and you walk onto a site and they hand you a whole bunch of data and ask you to make sense of it, here's a way to get started. Yeah, let's play crazy. And so this is a way of getting some being able to visualize what's going on. So let's have a look at the class diagram, bring it up in this, hide that, hide that. And this is what it's basically written out. It's written out a bunch of code that pulls this into a data structure. I'm not going to actually do it live on stage. I went from there, I got it to write a parser for the schema file and then a mapper from that in-memory representation of the schema file into that data file, into that data structure, yada, yada. Let's just close that out. So, I think I've gone through this. Netlist is a text description of the circuit's connectivity. The components, so this is resistors, capacitors, ferrite beads, MCUs, those sorts of things. and most importantly, the nets that connect them. As we went through, the KiCad netlist was actually designed for populating a PCB, so there's a bunch of things like footprints and additional information which is not required for our current problem. So what I'm going to do is I'm going to strip that down and give Gemini the ability to get just a list of components with values and the networks that join those components together. Yes, which we went through, Dart, write it to disk, we saw that diagram. So here's the solution. I'm going to parse a netlist file, expose the ability to list components, list the networks, and get this inside of Gemini CLI. So how are we going to do this? Well, as you may have guessed from the title of the talk, the primary actor here is Model Context Protocol. Who here has heard of Model Context Protocol? Most of you, I'm hoping. So what are you doing here? Katie's talk's next door and she's way more entertaining than I am. Okay, so here's the diagram from the MCP documentation website. It's basically handling the M multiply by N problem. So MCP was explicitly modeled on a thing called LSP. If you use VS Code, you know what LSP is because it's the way that pretty much all of the language services like C++, Dart, and as of the rewrite, TypeScript, integrate into Visual Studio Code and by now pretty much every other editor on the planet. It means that you as a language development environment provider can provide tooling to all the editors on the planet by creating a language service. Likewise with MCP, this is a way that a tool provider, in this case, wonderful little netlist provider, I can provide a service to all of the AI tooling out there, Gemini CLI, OpenAI Codex, Claude Code, and various other things, and give them the ability to use the tools that I've created or that other people have created to achieve an outcome. So to make it concrete, what we're going to do, Gemini CLI, through Model Context Protocol, is going to talk to some netlist tooling which I created. Does that make sense? Cool. So the tools I'm going to expose. First one is the ability to load a KiCad schematic file, that 555 oscillator.kicad_sch. Going to have the ability to list components in that file, list the nets in that file, and if it's really, really interesting, and I've seen it do this on probably 2 occasions, it will be able to get the details on a specific component. This might happen, for example, with an MCU if I ask it a question about the capabilities of the MCU on the circuit, for example. The dependencies, because I'm doing this in Dart, I'm using the Dart MCP package, but there are pretty much MCP packages for pretty much every programming language out there by now. I'm using Petit Parser for parsing the schema file. Well, actually, I had Gemini write the parser for me. Stream channel for handling network I/O because it's always a pain, and KiCad CLI for doing the initial conversion from the KiCad schematic to the netlist file. So, let's talk about testing MCPs. More importantly, let's quit out of here. Actually, no. Let's go here and switch to the main branch, which hopefully brings in some content. Yes, I've got some stuff. I might just throw away the changes because I don't need to confuse things. Bloop. Okay. Please excuse me, Dart pub get dependencies, good, got the dependencies. So, what am I about to do? So before I get into the point of running Gemini CLI with an MCP, I'm going to show you what's happening behind the scenes by giving you developer tooling and how that, oh, I've only got 5 minutes left. Oh, goody.
8 minutes.
Yeah. I'll have to skip quickly through this. Yes, I'll still run this because this is interesting. This is the thing you're going to have to do. Yes, I've done that. So, what are we doing here? We're running yet another node program. This one's created by Anthropic. It's part of their tooling they hand to developers to help them develop MCP tools. Okay, does this look right? Yep. Connect. Yay, it works. So we're effectively pretending to be Gemini CLI at this point. I can list the tools, I can load a schematic. Let's see if I can get this right. 555 oscillator with 2 L's, KiCad _SCH. Run tool, did it work? Please work, yay! And then we can list components and list networks. So basically, the thing I'm trying to point out here is that you want to be as light as humanly possible on the content you return. I've seen a lot of people, their first instinct with these toolings is to return absolutely everything. Don't do that. Your tokens matter. As proven earlier, or semi-proven earlier in this talk, if you give your LLMs too much context, they will drown. Yes, I had to fight Gemini on this. He wanted to use JSON, lots of JSON. Okay, so dev tooling, useful, use it. Okay, where am I? Cancel that. I am going to skip over the MCP server stuff. I basically step through adding the MCP, using it, and get on to the new part because we have less than 5 minutes left. And I want to talk about this, Gemini CLI Extensions. Who's heard of Gemini CLI Extensions? Ooh, cool. That's good. I was adding this to the talk at 3 o'clock this morning, so I'm glad that I get to tell you about it. Gemini CLI Extensions, like the problem with MCP up until now, is that as an MCP service provider, you gave a LLM a set of tools that it could use, but you didn't have the ability to tell the LLM how to use the tools, why to use the tools, what order to use the tools in. So we came up with this thing called extensions, which you can read about here, but I'm going to give you the high-level overview, and you'll notice MCP servers here. If I'd had time, we would have discussed what that was about. Really, it's just a way I showed you the demo. The important thing for me is the middle one. The one on the end is basically a Gemini MD where you can give it like a context, who it is, what its mission in life is, so on and so forth. The custom commands is where it gets interesting. Of course, there's a JSON file that describes what's going on here. This part in the middle should look reasonably familiar to anyone who's in an MCP in the past 6 months. It is this standard MCP server block. So the core of a Gemini extension is one or more MCP servers. But there is this thing here. There's a commands directory beneath or beside that specification where you can give it tools. These are slash commands, effectively. What I'm going to get when I link this in is I'm going to get slash review schematic with an argument which then gets fed into this prompt and then fired into Gemini. The reason this prompt is formatted this way, if we'd had time to go through the previous build-up, you would have seen me use increasingly wordy or verbose things to get just the result I want. But this is kind of where I've landed to get a useful result. So somewhere here, I lost all my things. Gemini extension link. Yeah, sounds about right. I'll just make sure I'm in the right directory. Yeah, that looks about right. So this is the developer version. There's a Gemini extensions install and then like a GitHub URL. Yes, I trust my own code. So now when I run Gemini, you'll see something interesting, hopefully. Using one MCP server, Control-T to review. So now here's the netlist, as I showed you using that NPX tool from Anthropics. Here's the things. We have the loader schematics, so on and so forth. and then list components. And I'll just get back to my cheat sheet. Yes. So instead of typing in a whole bunch of wordy stuff and trying to remember how to use it, I now have this magic shorthand which does that all in the background. So it's going to turn around, load the schematic, get all the, once I give it the option to do that, yes, use all the things, load all the components, load all the networks, all the nets, please. Hey, yay! And now it's going to think about it, and it's going to come back with hopefully a much better explanation of that complex network. And this is going to take a little while because it's actually got some thinking to do. So it's talking about the MCU, signal flows. This is so much better than yesterday. And it's calling out the dot stars. So there was a series of LEDs on the front that are addressable programmatically using a clock and a data line. They're really cute. But the fun thing is, now that we've done all that, we can actually dive in and start asking, and this is the whole reason I did this. Well, not this specific question, but I will be able to start asking it questions like, this circuit doesn't work. When I apply my digital multimeter across these two pins, I'm expecting a varying voltage and I see a resistance instead. What have I done wrong? But getting back to what I just asked it, I asked it to dive into, oh, still thinking. I've asked it to please expand on what the MCU is used for in this circuit. And once it figures out which way is up, it will turn around and hopefully talk about how the MCU is being used to drive the voltages to control the two parallel voices. And thus endeth the demo. Questions? No? Have I broken everyone's brain? Got a couple. I think this gentleman in the front row is number 1. And number 2.
Hey, Gemini Extensions.
Yes.
It's really useful to be able to have those slash commands.
Yes.
What is the capability, or is there a capability for the agent to understand that themselves? So you could just ask that question and it could go, oh, I need to use the /review extensions and load that file, sorry, review schematic and load that file and ask that, or is that kind of handled upstream of that and you do have to add that all into your prompt itself?
So one of the fun conversations I had at work was with a tech writer who had a fight with Gemini CLI where he kept asking Gemini CLI not to sit there giving smart aleck responses while it was thinking. And he convinced it to not do it, and then it kept doing it. The thing to understand here, and I know it's somewhat confusing, but there is an architectural problem. What you're thinking is upside down. Gemini CLI, the only thing Gemini does is predict the next token. It has no visibility of the slash commands. That is purely Gemini CLI, which is a node program that runs on your computer. Gemini itself is in a data center, and all it does is it gets a stream of text and it generates more text tokens. So yes, to answer your question, Gemini, the API has no visibility of the fact that the slash commands exist. That's purely a client-side innovation. So unfortunately, no, it couldn't figure out that it should be using the prompt that it has no visibility over.
And then follow up there, is that MCP server loaded by the extension only available through the slash command, or is it available to the root agent running in Gemini as well? Like could the root agent call those functions on the MCP server?
So to answer that question, the MCP server is, as you can see, fully listed here. So I can just do there are already, if you go to the GeminiCLI.com/extensions page, there are already hundreds of extensions listed there, including one for my favorite little Flutter environment, and it includes tools and it's decided to run off and do other things. The wonderful thing about context is anything that's in the context continues being in the context. So it looks like it's retained the direction to go and explain what the MCU is doing, I think. Yeah, it has. The thing that I'm trying to get to with this talk, and I think I probably got there, even if it wasn't by the path I was planning, is be careful what you put in your context. There is no way to tell an LLM to ignore something that's there. Any more questions? Actually, there was a second one up there.
Yeah, we have a question over there.
Is there a third question that we should queue up? Or do I get to do interpretive dance?
Ooh, can you answer with interpretive dance?
I can try.
Cheers. Obviously, this is just a different interface for Gemini, just using from the CLI. Is there any advantage of this over any other interface, like a web interface? Is there better file access? Is there better command execution or something?
Being really, really stupidly flippant, which I'm allowed to, I've got grey hair, it's running in my running in my terminal. So it has
personal preference of where it is.
It has all the powers and problems of that. So it's running on my computer, has access to my file system as long as I say, yes, you're allowed to read and write. Well, actually, I think it gets read for free. It's just writing that it asks you about. So where and how you run Gemini really depends on your use case. I use Gemini through Firebase AI logic inside of Flutter applications that I run on my phone. Makes complete sense. And in fact, the follow-on to this will be a Flutter application that I can then sit there and have a conversation about a circuit on my phone. But yeah, as a developer writing code, being able to turn around and point Gemini at some code and say, please read this and write some Dart code for me. I can't do that from, can't do it easily from a web-based thing unless I turn around and also have a web-based IDE, at which point I have all the problems of web-based IDE, i.e. latency to Singapore.
Cheers.
Thank you. Third question here.
Yeah.
Do we have a fourth question? Or have I just fried all your brains?
Sorry to anybody who wanted the interpretive dance. Those parts you skipped in about NCP server, are those available somewhere to look at later?
Sure. I will be in the hall. More than happy to answer questions. I'm around for the rest of the afternoon. More than happy to go through those slides because I think personally that understanding how and why and when to use MCP servers to empower you to expose your workflow to an LLM, any of the LLMs, because as far as I'm aware, all the major LLM providers, including Llama, do some version of MCP. So this is a way, as I assume most of you in this room are software devs, this is a way that you can get your work into an LLM of your choice to do decision making. So yes, that's a well worth investment.
Okay, do anyone have more queries for Brett? Yeah, that will be the last question for yeah, that would be the last question for today. And yeah, obviously you can chat around with Brett. He's here.
So I saw you dissing JSON as a format as being a bit, I guess, verbose. Was it YAML you had there as the output?
Yeah, it was. It was.
Or some kind of formatted. So I guess, is there any difference in the way that you'll get a response because you've captured that way? Because originally it was trained on one version rather than another? Or is that something that's so abstracted away now with the amount of training that you don't have to worry about it?
I've seen reports that say using XML tags can be useful, but don't use it as actual XML. Use it more like HTML, but you can use whatever tags you want because it's still reading them just as information. What I was really getting at is that when I did most of the code for this vibe coding style. I wrote out a mini spec and then had a shouting match with the LLM to write me some code, and then I went and corrected it. And one of the things it really wanted to do was be quite verbose in its responses in a structured format. And it's sort of like, no, I just want to return a list of nets. So if I choose a lightweight-ish, as you point out, is probably YAML. Realistically, all the LLMs have seen all the content. So as long as you pick a reasonably sane and most importantly, reasonably light character-wise way of representing your data, it will probably do quite well. But at that point, when you've got something that's working, please experiment with different types and see what different results you get depending on which LLM you're using and something that you need to do every time you change LLM providers or the LLM provider you're using ships a new version. The thing I'm pointing at is the thing that is coming out of YC and various other startups. The thing you need to build is an evaluation regime. You need test inputs, test outputs, a way of figuring out whether the outputs are good or bad. Who knew testing actually matters?
Yeah.
And
Thanks a lot.
documentation.
Thank you so much for your thoughtful questions. And thank you to Brett for such a fantastic walkthrough.